problem up on the board, I want us to do two things. First of all, given this polynomial, I want to just state what the lead term is, and then I want to describe the end behavior. And I've just reminded us that that's both sides. So that's looking at what happens as x goes to infinity and what happens as x goes to negative infinity. All right, so if I look here, remember that the lead term is not necessarily the one that's written first. It's the one that has the biggest power of x. And any sign in front of the coefficient is part of that term. So the first part, the lead term is negative 5, x to the fourth. Then for question 2, I can say as x goes to infinity, f of x is going to do exactly the same thing as this piece does. Wherever this wants to go, it's going to drag the other terms with it. So if I just look at the power, x to the fourth would be going off to infinity. We're multiplying by a negative, so that's going to reverse that, and we're going to go off to negative infinity. And then as x goes to negative infinity, what's f of x going to do? Well, because that's an even power, the fact that we're going to negative infinity doesn't matter. The even power will go off to positive infinity. When we multiply it by a negative, that's going to make it go off to negative infinity. You'll notice if your lead term is even, your end behavior should be the same on both sides. If your lead term is odd, your end behavior should be different on both sides. All right, let's try this same problem with a different polynomial. Let's say I had p of x is equal to x squared times 2 minus 3x cubed. Okay. So here, I've given this to you in what we call factored form. It's not all multiplied out, so it's not given to you as a sum of power functions and constants. It's a product of things. So it's a little bit harder to pick out the lead term, because I don't have just a bunch of terms that I'm adding and subtracting together. But I know that this would mean x squared times 2 minus 3x times 2 minus 3x times 2 minus 3x. And I basically have to multiply everything out. So I'd be distributing the x squared to the 2 and to the negative 3x. And I'd be distributing this 2 to this 2 and this negative 3x. I'd be distributing everything to everything. What's going to give me the biggest power is going to be if I'm always multiplying every piece with an x in it. So if I multiply the x squared by the negative 3x, by the negative 3x, by the negative 3x, notice that would just be x squared, and then the lead term here, negative 3x cubed. So if I take the lead term in each factor and raise it to the appropriate power, that's going to give me the lead term of my polynomial. So my lead term is going to be x squared times negative 3x cubed. Now that cube will distribute to the negative 3 and the x. Powers do distribute over multiplication, because I can see I've got 1, 2, 3 factors of negative 3 and 1, 2, 3 factors of x. Powers don't distribute over addition and subtraction, but they do distribute over multiplication and division. So that's going to be x squared times negative 3 cubed would be negative 27 times x cubed would be x cubed. So let's see, that's just negative 27 x to the fifth. Remember, when I'm multiplying powers, I just add the exponents. That was 2 factors of x, that's 3 factors of x, that's a total of 5 factors of x. Okay, so with that, I can now say, as x goes off to infinity, p of x is going to do the same thing that this lead term is doing. So, any power, if we're going off to infinity, goes to infinity. Multiplying it by a negative is going to reverse that, so we'll get negative infinity. As x goes to negative infinity, p of x, let's see, now it's an odd power going to negative infinity. Odd powers would go to negative infinity. Multiplying by a negative will change that to give us infinity. Notice my lead term was an odd power, and I got opposite results for the end behavior. That's always going to happen. Okay, I'm going to keep these directions up and just put up two problems for you to try following these same directions. So part A, let's go with h of x equaling 7 minus 8x to the fourth plus 2x cubed. And for B, let's go with r of x equals x plus 2 squared times 3 minus x to the fourth times 4 plus 2x cubed. So for both of these, I want you to first of all state the lead term and then describe the end behavior. So what happens as x goes to infinity and as x goes to negative infinity. Pause the video, tune back in, and we'll compare answers. For h of x, this is all multiplied out, so I just look at the terms, which are the things I'm adding and subtracting together. I look for the one with the biggest power. Okay. So the answer to part 1 is that it's negative 8x to the fourth. Do just be careful, that negative sign is part of that term. That's part of the coefficient in front of the x to the fourth. And so then I can say, as x goes off to infinity, h of x, well, any power as we go off to infinity goes to infinity. Multiplying by a negative is going to make that go to negative infinity. As x goes to negative infinity, h of x will go to negative infinity. Since that's an even power, just the power part is still going off to positive infinity. Multiplying by negative 8 will reverse that and give us a big negative number instead of a big positive number. And again, you see that the lead term was an even power, and you have the same behavior on both sides. All right, there's a little more work to do for part 2 because I gave you that polynomial in factored form. So in finding the lead term, what I need to do is look at the lead term in each in each factor, and take it to the appropriate power. So here, with x plus 2, that lead term would be x, but I'm going to have two of those. So I'm going to have two factors of x. That'll give me an x squared. For 3 minus x, the lead term would be minus x. I'm going to have 4 of those factors, so that's going to give me 4 factors of a negative x. And then for this third one, the lead term is 2x, and I'm going to have 3 of those, so I'll have 2x cubed. So we've got x squared. The opposite of x to the fourth power, since that's even, that's just the same as x to the fourth. And then I'm going to cube the 2, that's going to give me an 8, and I'll cube the x, that gives me an x cubed. So that gives me 8 copies of 2 factors of x plus 4 factors of x, that's 6, plus 3 more, that's 9 factors of x. So we've got 8x to the 9th is our lead term. So now I can say, as x goes to infinity, r of x is going to go to infinity. Pretty much, if I'm going off to infinity, I just need to look at the sign of the coefficient. I know all powers, even and odd, are going to be going off to infinity. So if I'm multiplying by a positive number, I'm going to be going to positive infinity. If I multiply by a negative, I'd be going to negative infinity. But when x is going to negative infinity, I need to be a little bit more careful because the end behavior of the power part is different depending on whether the power is even or odd. Now, since 9 is odd, x to the 9th would be going to negative infinity. When I multiply that by 8, I don't change the sign, so r of x will be going to negative infinity. Notice the lead term was an odd power, and I've got opposite behavior on the two sides of my graph.